All right, let's see if that is that better. Let's try that out. Can you hear me all right? Okay, cool. Yeah, just I'll probably be posting the. I mean, I've tried to post the video about 5 minutes before 9, and then just like okay, we're ready to go is very helpful for me. I can't see what's going on, and I don't want to start without you. So, especially if it's a technical issue, I want to sort those out. Awesome, thanks everyone. Okay, so we got another big day. I feel like yesterday's a bit more. There's a bit more to yesterday. It's a little. I have to rush a little bit more to get that much content because we have to talk about HTTP and how to make requests in Node. Today we don't need to talk as much about HTTP because we've learned a little bit about that. Although just keep in mind that today is still about HTTP, even though we're writing a lot of JavaScript. So it's all about web servers today. That's what we want to build. We're going to take our JavaScript and what we know about HTTP, and then build the receiving side of a request. So the side that's responsible for giving a response back. So I've got this picture up here of a bunch of web servers. Could someone maybe tell me what they believe a web server is? Web server receives a okay. So it's something. What is it? A computer. Okay. So a computer that receives a request and then sends a response back. If we go a bit farther than that, it's actually a piece of software. So a web server is typically a piece of software, even though when we see it in the movies and we see servers on in photos and stuff like this, they look like it's hardware. But hardware is just the house for the software. It's just the place where the software runs, and the server is actually the software. That's what we would consider to be the web server, is the software that accepts those requests and then sends the response back. And that's really what this week's project is about, is building one of these things. And we're going to be using the Express framework, which is the most popular Node framework for writing web servers. As Don puts it, it is a kind of today, or this project is you're going to culmination of everything you've learned up until today. So I know it's only been 6 days, but you learned a lot last week, right? And even yesterday we learned a lot, and all of that stuff that we learned is going to have to be applied to this project. So what are some of the JavaScript things that we've learned that we think might be useful in building a web server? Just guesses is fine. Yeah. Yeah, cool. Yeah, so functions that take in inputs and then they have outputs. They maybe trigger certain actions. We're going to definitely be using functions that take inputs, and the majority of the functions that we write are going to be what we call handlers, and these handlers will accept a request object and send back a response object. And this is what we're going to be using in Express. So I'll show you how the handlers work, but definitely have to deal with functions and the asynchronous calling of these functions. What else? What about objects? How do we feel about objects? Good about objects? Okay, so objects are going to be our primary data structure. We're going to use an object to store the data for our web server. It's kind of a this is sort of a step into how we could do it with a real database. But right now we're not going to worry about databases and persistent data. What's going to happen is when your app loads, you're going to create an object, and then when people add new records or resources to your application, you're going to add those into the object. Unfortunately, when you bring your server down, that object goes with it, and when you restart, all that data will be lost. But that's just what happens when you store your memory, your data in memory only. So we'll use objects for that. We'll have to do object lookups and adding to objects. So that's definitely going to be something we'll have to do. Anything else? Sorry? Core modules, yeah. So we're going to be using modules. Most likely for this exercise, we'll be using modules provided by third parties. So Express is one of those modules. We'll install that using npm and then require that, and then read it about its API, read its documentation, and then figure out how to use that. And if you feel like pushing yourself a little bit farther, you could think about how you could break this app up into more different files and modules yourself. Definitely not a requirement this week, but it's more of a stretch as far as I'm considering. Okay. HTTP, we're going to use get and post for most of our the responses that we'll send back. We'll be responding to get and post methods. So yeah, it's pretty exciting. It's called Tiny App. It's in no way a tiny app. It's really it is a pretty complicated project, but I think it does a pretty good job of representing sort of all the different actions you might take on a web server. The ability to add new resources, view those resources, delete those resources, change those resources. These are all the types of operations that we need to do with a web server. So what is a web server? I should cover that first. We want to talk about what it is. Yeah, it's a piece of software running on some machine somewhere, but we need to know how we actually find that machine over the network, how we can make requests to it. So I'll talk about that. I'm going to show you an example of how we can handle requests just with Node and the HTTP library, the same HTTP library that you used yesterday. There's a create server function that we'll use, but we'll quickly move away from that and then do an example with the Express framework, which is where you're going to spend most of your time this week. And then EJS stands for Embedded JavaScript. So we're going to be writing template files. These are like HTML files, but they have a little bit of JavaScript in them. And so they get processed before they're sent back to the user. You'll see how that works. This is how we get dynamic responses, not just static HTML. Okay, so what about servers? There are many ways for clients and servers to communicate with each other. But one of the more common ways, and the way that we use with HTTP uses, it's the request response model. So we got this client. Client makes a request to the server. Stuff happens. This is what you get to decide what happens here, right? Maybe you connect to a database, make a call to the database, grab some data from it, and then send all that data back in the response. Maybe you're just, I don't know, creating a new file or actually having it upload a file, maybe an image, a profile image or an avatar image or something like that. You send the request to upload this image. The response comes back, yes, we successfully received that. The stuff that happens is saving that image to the actual file system so that it can be called up later. So that stuff that happens, that's huge in scope, all the possible things. But we're going to keep it quite simple today and send back a little bit of HTML. All right. So you can have many, many servers running on the same piece of hardware. This is where hardware constraints come in. This is where, so the more memory a machine has, the higher CPU speed a machine has, the more of these servers it can run at the same time. Or if you have one server running, the more requests that server could potentially handle at the same time. So when you create a new, I guess, machine, you can install a database on there, you could install a Minecraft server, you could install a web server. All these things can all run on there at the same time, and in most cases not have any problem or conflict with that, as long as the machine has the resources to support it. And most people, I'm sure everyone here, has connected to non-web servers before, whether it be for games or maybe chat or something like that. Yeah, they exist all kind of size. But if I can have multiple servers running on the same machine, I need a way to make sure that I'm connecting to the right server, right? So we start this off by talking about how do we find this physical machine first on the network, right? There's something called the Internet Protocol. That's what IP stands for, Internet Protocol. And there's a specification for this, and in the specification I pulled out this little, I wish it was a haiku. I kind of wish this was a haiku, but I don't think it is. Definitely isn't. But it kind of explained in pretty simple terms how we can find servers on the network, on the internet. And so the first line, it says a name indicates what we seek, right? So if I want to sign up and go to a web boot camp, I need to go maybe to lighthouselabs.ca. And I know that, so I type in lighthouselabs.ca into my browser and I hit enter. But lighthouselabs.ca is not the address to my to the website, to the actual server. What it does instead, and we don't see this happening, is it makes a request to another type of server called a DNS, a domain name server. And a domain name server maps lighthouselabs.ca to the IP address that lighthouselabs.ca server exists on. Okay, so that's an address. Address indicates where it is. This is the actual IP address, recognizable as 4 sets of numbers up to 255. Each number can be up to 255, split but with dots. So 1.1.1.1, 127.0.0.1. Those are IP addresses. And so the DNS maps this name, lighthouselabs.ca, to this address. And so every time I need to find out what that address is, I can do that lookup, find out. And then once I get that address back, now my browser can actually make the connection to the web server and make the request over HTTP. Does that kind of make sense? Okay, so we've got two servers. You actually connect to two servers every time you type a URL into the address bar. The DNS and then the web server, potentially, right? Okay, so there's a third thing which we won't get into detail, but a route indicates how we get there. So we don't connect from, I don't connect from this machine directly to the lighthouselabs.ca web server. My machine doesn't connect directly to that. It actually connects through a bunch of different routers, ISPs, other machines that are there to route our traffic. So I can kind of show you what this looks like. On Mac OS, there's something called the network utility. And if I want to, I can find what is my IP, and I want to find my external IP, right? Because if I connect to a wireless network, this machine gets an internal IP, and your machine gets an internal IP, and your machine gets an internal IP, but we all end up sharing the same public IP. And so here it is. I've just typed in what is my IP into Google, and they've told me it's 162.245.144, etc., right? Or if I want, I can do a quick lookup on, let's see. Maybe I'll just do lighthouselabs.ca. I'll ping this. And this is actually giving me access to lighthouselabs.ca points to this IP address. So if I want to connect to this web server, I am actually able to try that out here. No, it doesn't like it. Direct IP access not allowed. I'll explain why that is later on. But let's see what the route is to that. So I'm going to open up this tool called traceroute. Make sense? Traceroute. It'll just trace the route from me to the server that I'm looking for, or to the IP address that I'm looking for. I run this, and we see these are actually the machines that I connect through to get there. Okay. So we have the name, the address, and then the route to get there, and all of that stuff is defined through the Internet Protocol. Roughly make sense? Okay. So now I've got this, I'm actually able to connect to this machine through its IP address that I looked up through DNS. And now I need to decide sort of how do I connect to that specific server, the web server, rather than the Minecraft server. And the way that this happens is each of these servers, when they start up, they grab a local port on that machine. And then that port is what we use to connect. So these are virtual ports. They're numbered from 1 to 665,535. And we choose numbers like 3,000, 8080, 5,000 for our local web servers. And the reason why we're choosing these higher numbers rather than 12 or 15 or 62 is sort of because anything in that lower range up until 1024, you must have administrative access to start a port, to open up a port on a machine, a port within that range on a machine. You need to have admin rights to do that. So it's really kind of just easy for us to just open up something on 3000. Does this kind of make sense too? Right? Every server that's running on that physical machine, or virtual machine, I guess, will have a different port that we connect to. We'll use the same address all the time, just a different port. For HTTP, we're connecting on port 80, not in development. On development, we're doing 3000 or 8080 or whatever it is that the assignment is sort of instructing you to do. But when we put this out there for the world to see, we're going to open up port 80 as an administrator and have people be able to connect to that. And then that's going to allow people to access our web server. And if you're running it securely, which I recommend everyone does when they go out into the real world and they put out a production server, production app, then instead it would use port 443. One thing you'll notice, whenever I go lighthouselabs.ca here, I hit enter, it still finds it. It knows that the default port for a secure connection is 443. I don't have to put that at the end of this. But it still works, but I don't have to do that because we're using the defaults, right? Cool. Hey, there's David. Oh, not anymore. Okay. So primarily 2 ports now. We're making this effort to move just to the one to HTTPS. We noticed last year the numbers went way up. We've got way better support for this, and it's way easier to make your site secure these days. So web servers are software, some of the most popular commercial or open source options out there. Apache's #1 has been for a long time. Exploded with the popularity of PHP in the early days of the web, 1998, 99, 2000, etc. And so a lot of people are using Apache, definitely #1. I personally use Nginx these days. It's #2, kind of in popularity. And I mean, you can get away with either of these. There's not really it's kind of a preference thing. Try both and then decide. IIS, though, is the third one out there, and I only put it on there because it is #3, and I like this podium kind of metaphor, I guess. But let's think about what does anybody familiar with IIS? Yeah. It's a web server not made by Google, though, but another big company. Yeah, that's right, Microsoft. So if you're building applications using the Microsoft tech stack, like .NET and all of the C# and all the stuff that they provide in terms of tech stack, chances are you'll be running that on a Windows machine using IIS. So it's #3 for that reason. I'm not going to do that. I'm going to run my web servers on Linux. I prefer it. I think it's more stable. I don't need to buy a license for Windows then, all that kind of extra stuff. But it's still on there, and I don't know how. I don't think that'll change. So. Yeah, I want to call this out quickly. So this talks a little bit about, or this shows a little bit about what maybe a machine that runs multiple web servers at the same time could look like. And so let's say that you have your machine listening on port 80 for any connection. And when someone makes a connection to that port, you need to make the decision whether or not they're accessing site A, site B, or site C. And so site A could be running as a Ruby on Rails application. Site B could be running as a Node application, and site C could be running all as a PHP application all at the same time, but they're all using different ports internally. Does that kind of make sense? Okay. Now, today we only care about this part of it. This is where we're working today. But I want to talk a little bit about this little problem that I ran into. Direct IP access not allowed. So this machine, or this system, looks like hosted by Cloudflare here, or at least there's a layer on top at least. Direct IP access not allowed. There's a reason for this. The way I expect that this machine that our web server is running on is also running other web servers. It could just be Web Compass. It could be our Compass site and the actual client-facing kind of marketing site. It could be someone's site we don't even know who they are, because when you decide to set up hosting, sometimes you can set up hosting on like a shared server, and then other people are paying to host on maybe that same hardware. But the point here is that the way that it figures out which web server we're actually trying to connect to is through the lighthouselabs.ca name. So when a request is made, to port 80 here, then Nginx, which is the web server that's running and accepting all connections, is going to look at that and say, well, which actual host name, what was the address that you were looking for? And it can find that in the headers of the request. So it uses that to figure out, oh, lighthouselabs.ca, that's port 5000. So I will forward that request to port 5000, and then that server will handle that and send back the response, okay? And maybe another request comes in to webcompass.lighthouselabs.ca, and in that case, it gets routed to the Node app on port 3000 because it's a different host name. So based on the host name, Nginx can decide to send to a different port on that machine. And this is how we have multiple sites running on the same machine. This is a bit complicated for right now, I know. I tend to bring this slide back up maybe in week 8 or 9 when we talk about actually deploying sites to the web. So remember today, we only care about this little node section right here. Okay, yes?
Can I just repeat back what you said so I can understand? Make sure I.
Of course. Do you want to repeat in here? Okay.
sometimes, this is me confirming my understanding, this is Shmoo, hi Victoria, sometimes if you just have the IP address, you can't pull up the website because many websites are being run on the same server with the same IP address. So if you use the URL and it gets sent to the DNS, then the DNS can use the URL to find which port that particular site is coming through, right? Sort of. And then, so it sort of like adds that information to the IP address, so then it gets sent. The browser knows the IP address and the port, and that's how you can access the website?
Very close, very close, yeah. So the only slight confusion there is the DNS doesn't care about ports at all. The DNS only cares about mapping lighthouselabs.ca to the address. And so if you have 10 sites that all point to that same address, then the DNS is always going to, whenever you ask for any of those 10 sites, it's going to give you the same address for any of them. Okay. But now I know what the address is, so I can do an HTTP request to that server. And when I make the HTTP
server needs the URL.
That's right. Yeah, the server needs to have that host name to then figure out which port to forward the request to. Does that make sense for other people too, kind of? Okay. Again, we don't need to fully understand that, but I think it's worth showing that sort of how this kind of works in the wild. But today you're just running this node server on port 3000 or whatever, so we don't have to worry about Nginx and port 80 and even production servers these days. Okay. So I'm going to talk. I'm going to do a code example here with requests with Node, and today I've sort of set up a brand new project. We're going to just start it from scratch, and it's going to be a basic web server. Let's see, kill that, get rid of that. Okay. So I'm in this web servers live directory, and if I list it out, we can see. Oh, there is actually that was a mistake. I'm going to go back. I'm just going to remove it and then make it again. Okay, now when I list this out, we can see there's nothing inside this directory. And so whenever I'm building a Node application, the first thing I want to do is npm init. This is going to actually create a package JSON for me and make this a Node module. I'll run that. I can accept most of these defaults here. Kind of like to put maybe my name in here. I'll put, I don't know, like MIT or something, kind of license that I prefer. Hit enter. And so now, take a list. Okay, I got my package JSON set up. This is now a Node module. That's all it takes. I also want to create a new file, and this is going to be my, I guess it's going to be just my HTTP server.js. Okay, so this is the first example where we're actually going to use the HTTP library. So I should probably also open this folder up now. All right, here's my HTTP server, and if I go over to the Node.js site and I take a look at their About section, we'll notice something interesting. They have a great example here. Most libraries, most code examples, they start with a hello world. They say this is how we do hello world in this language. Hello world in JavaScript, hello in Ruby, hello world in Python. Here's hello world using Node HTTP as a server that sends back hello world for every single response. Okay? So we're going to take this because HTTP is so built into Node. That's what it was created for, this purpose. This is the roots of it. This is their example. I kind of like that about them. And I'm just going to paste this in here. Now, you're going to notice a few things. This code is ES6 code. And we don't talk about ES6 until this afternoon officially, right? So we got a decision to make. Do we just quickly accept some new understanding on this, or maybe don't know the fully understand some of the things, but we continue to use them? For example, const, that would be new for some people for sure. You could put var in here instead, and this app will run the same way. They are different, but the app will run the same way. So whether or not I make this var or const, the app will work the same way. Do we care if we continue this way, or should I just stick with ES5 until after this afternoon? Everybody's good with const? Okay. I'll just stick with const. May as well get warmed up. The idea here, though, is if I tried to say HTTP equals after this, const would not allow that to happen. I do not get to reassign to this variable. That's really the difference between var and const at the basic level. It's declaring a couple variables here. One for my host name, one for my port. These are pretty good values. I'm just going to keep this the way that it is. This is kind of the most complex part of, I think, to understand for this. Let's quickly get this part out of the way, though. This is an arrow function. This will be new syntax that we'll learn again this afternoon. If I were to do this instead, for the purposes of this code, those two work the same. For the purposes of the other code, they do not act exactly the same, but for today, for this, it won't matter. So stick with arrow functions. Okay, do that. For today, it's just going to look like nicer syntax. Now, the other thing that I like to do, for me, it's true. It is my belief that anytime I copy any code from somewhere else, it becomes my code. And so this code, I should make it mine. I should make it the way that I would have written it if I wrote it from scratch. Therefore, I'm going to type some more here and put request response in. I don't like shorthand for this, especially when I'm teaching, because let's think about all of the possible things that res could mean. Oops. Not that. Result. I mean, even these two are enough for me just to say, I'll just use the full thing so I know exactly what it means. It's not the result, it's the response, especially in this context. That's important to me. But you should feel free to use the shorthand if you want, because it is quite common to see that, especially since we're noticing they're doing that on their examples anyways, right? But my preference is don't just have one character difference between these two things, because they're hard enough to tell the difference as it is already, right? And you're going to be using, most likely in a lot of these handlers, you're going to be using both the request and the response in there. You're going to be grabbing information from the request and then building up the response that gets sent back. So you're going to be kind of using rec and res. I find the longer version just is less confusing. Okay. So let's run this thing now that it's mine and see what it gives us. So now it tells me I've created this server, and then the server that I created, so this create server returns to me some server object. I've created that now here as a server variable, and I can call server.listen, pass it the port and the host name, and then also a third option, which is a callback, and this callback gets called when the server is running. So if we look at it, my output is what I would expect. The server is running at 127.0.0.1 port 3000, and that came from this. So my expectation is that the server is running right now and I can make requests to it. I can type localhost or 127.0.0.1. This is my little DNS, my little local DNS. Anytime I try and do a lookup to 127.0.0.1, that maps to localhost. Well, actually, I think I overwrote it down here and said that this other sort of development that I was doing, I wanted to be able to use the URL locally that represented what the actual URL would be outside, so I was able to remap it here. But this is how, so 127.0.0.1 or localhost, you can use those interchangeably. And if you do the same thing I did, which is cat etc hosts, that's going to list out what your hosts are, and most likely it's just the defaults that we see here. Okay. Although I don't know about in Vagrant. Okay, we're running the server. We'll make our connection, and we get back the response, hello world. I'm going to bring up the inspector now because it's a good idea to have this up all the time when we're doing this stuff. Okay, reload. Here we go. I made the request to localhost. It was a GET request to this URL here. We see that what the remote address is, so it's done the lookup for me. It's a GET request, and I got back a 200 OK. We can see that the response has some headers as well. The length is 12. Okay, so let's see. This is the entire response. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12, right? Because new line is one character. Even though it's represented as 2 in here, it only counts as 1. So this is where our content length came from. It is the number of bytes in this, what we sent back in the response. It's also saying here that the content type is text plain. So you'll notice I set that here. So I can set headers before I send the response back. And so this is one of the ways we could do that. We'd say that the content type that we're sending back is text plain. Could also say maybe it's text HTML if we wanted to make it HTML. And now I need to restart this server because I've changed it, but I can go make my request again, and now it looks a little bit different. And if I look at my response now, it's saying it's text HTML instead. So render this as HTML, right? Yeah, for sure. And that's because we added more characters, right? So we added 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. So that makes sense. Anything that we put in here is going to be counted. It's all just a string, and each of those characters in the string counts as 1 byte, and the content length would be the number of bytes in the that was sent back. Okay, feel good so far? I was also able to send the status code here, 200. I can set that. So if I didn't find what someone was looking for, maybe I set the status code to 404 and then send the response back. Let's kind of see what this could look like. So we know, actually I'm going to keep running this. I'm going to put / about. Oh, it can't be reached. I got to start it up again. Let's do that. All right. Try this again. Now I'm going to / about, and I still got hello world. And then I go to / whatever, and I'm still getting hello world back. And so this web server only serves one piece of content. It's hello world, and there's no sort of concept of different paths, really. It doesn't matter what the path is, we always send the same response back. So what if we wanted to say well, I guess here we'd say if the path is the root, then we'll send back hello world. Otherwise, send back a 404 because we don't handle that route. So this is kind of how we start to think about this, right? We need to actually set up some conditions here, and now we need to look at the input, that request that's being made, figure out maybe the method, figure out what path it is, and then based on that, do some stuff to send, and then send the response back. I'm going to set this breakpoint here and restart it, just so that we can get a little peek into this request object here. The request object that's sent into this handler function, this will get called every single request that's made. That's what create server does. So create server, we give it a handler. It's a callback function. And every single time it accepts a request, it calls this function and passes us a request object that contains all the information that we might need about that request. But it's not plain text, it's an object. It's nicer to work with in JavaScript. It also passes us a response, but we'll talk about that in a second here again. The request looks like this over here. The HTTP version 1.1, we saw that yesterday, the method, get method. And then somewhere in here is the URL. There we go. That's what I could use to figure out what they're actually looking for. If they put / about, then I probably want to send them the about page. And if they just have / the root page, I want to send them the home page. And if they have go to / contact, maybe it's a contact form that they can submit. This is how we're going to decide that, is based on this URL that we have. So I'm going to say here, not if the path is, because unfortunately, well, I don't know if it's unfortunate or not, but they didn't call it path. If the request, .url is equal to /, then this is the response we want to send back. Else, well, we'll take the response, and instead of sending a 200 back, that means we don't handle it. It's a 404. So here my logic is, if I handle it, send 200, set the text to HTML, send that HTML back. Otherwise, set it to 404 and maybe put a not found. And we know that people create their own not found pages and send those back, right? I know that GitHub has a pretty cool one. This is where you could do that. You could say, when I don't find that page, I send back this cool HTML instead that says 404 on it. Yes? Mm. Yes. So the question is, could I just put an HTML file here? I couldn't do that specifically because this is the HTTP library. It's at a pretty it's a little bit lower level. So they basically just say you just put content in here. If I wanted to load a file and then put that content in here and send it back, I would actually have to do something like fs.read. Oh, come on. Read file, and then or let's say sync, and then now I give it index.html here, and then it gives me back the contents. This is a very kind of contrived or example that probably wouldn't work directly, but it's more like this. If I have to load that contents first and then send the contents in my end doesn't know how to accept a file name. It would just send the word index.html if I were to do that. But with Express, since it's built on top, they give us a whole bunch of different methods we can use on the response that are not end. I mean, we could use end, but we won't use that anymore. Instead, we could use things like render, and that's a way we could give it an HTML file that will actually we'll do that today with EJS. Another way is, I think you could do send file. I think you can send file with Express. Just send is one thing. If you just want to send some plain text, you could do it that way. .json is another way. So when we add Express on this, it opens up the doors and allows us to send a lot more data back in the response easily. Cool. But yeah, it's a good concept because that's what we want to get to eventually. This is all what we're trying to move from. Yes. Yeah. I'll show a quick example of that. I'll include that. And so for Sammy, I will be showing the Express stuff after the break. We'll do the whole thing again with Express. And that's where we'll be spending most of the time is in Express. This is really just to kind of show you where we started and why Express exists is because we don't want to be writing our web servers like this, okay? So I'll get through this part here a little bit quickly. Let's say go back to not found and just test this out quickly. Oops. Okay, so here now I only handle one path, and everything else is a 404. I run my server, and now when I make the request to /, I get hello world. But if I put / about down, I get not found back. And it doesn't really matter what I put in here. That as long as it's not the root, I'm going to get not found back, including the status of as a 404 not found. Okay. So we can imagine that this could get quite awful because at some point I might add another page, and so I say else if request.url is equal to / about. Okay, now I want to handle this. Take my response here. Okay. Reload this thing. And so now when I go to / I still get hello world. When I go to about, I get about world. And then when I go to anything else, I get not found. And so how many routes do I want to add to this one function? It's getting out of hand. I actually kind of prefer the idea that each handler, each different route that I want to handle, is in its own function, and the logic for that is in its own function. And so I break these handlers up in their own functions, one for root, one for about, one for not found, etc., right? Be a all right way to do it. So we could do that still without using Express by just using by using this in a little bit of a different way. And what I'm going to do is I'm going to create a lookup table. I'm going to create a thing called routes. And this is going to be an object. And my routes object is going to have a list of keys that are the routes that I handle. And each of these is going to be a function. And so the way that I handle my about as well is with a function. And actually, like I can just do it this way. Oops. Okay, so as you can see, now it's a little bit of a different process to add a new route, but to me it's a bit more clean, right? I'm not doing this if-else condition. I'm just saying this path or this route maps to this function. This route maps to this function here. And if I want to add something new, I would add it to here. And then my code down here, I guess I just take some of this stuff, put it in here. And then I could take the about one as well, put it in here. And I guess I'll just copy that. All right, so now I've got my 3 different handlers, and it's a lot. I think to me this is a lot more clear what's going on. And the reason I'm showing you this is because this is kind of more like how Express likes to handle this, and so this is the transition into that. So we define these routes here, and then down here, my logic is slightly different. I'm still going to need this 404 not found, because if my route is not in this object, then I don't handle it. So the first thing I want to do I want to check to see, is the route, that path someone's looking for, in this object? And if it is in there, then we'll call the function and that will send the response back. But if it's not in there, then I want to send a 404 back. So what's a good way, because remember I said we're going to be using stuff that we learned. What's a good way to figure out whether or not something is inside of an object? A key is in an object. Might not be as complicated as you're thinking it is. It's a few ways too. Sorry? Loop over? Yeah, I could loop over it for sure. But what's great about an object is we get constant lookup, right? We can actually look up for items based on their key. Whereas with an array, if we don't know what the index is, we have to look through the whole thing to find it. But in this case, we could just do a lookup on it. And what happens when we look up something and it doesn't exist? What do we get back? Yeah, and it's falsy. So if we put in false here, well, or a falsy value, which really just could be routes request.url, if this exists, well, then we have a handler for it. A function is truthy and undefined is falsy. So this would be a good enough condition. We could also say if routes.has own property request.url, that would be another way to check to see if that property is in there. A few different ways to do it. I'm going to just use this lookup here. So if this exists, then I want to take this thing. What is that? What is the only possible type of value for this? For this thing here that I'm looking up, I guess sorry. If it's now that I'm in here and I've checked to see, we know that the thing I'm looking for exists, right? So it's able to look up in the object for this key. What value do I get back? It's a function. It's always a function, right? It's a function if it's /, it's a function if it's / about, and it's a function if it's / contact. And it's always a function that has the same signature. It's always a function that takes a request and a response object. So therefore, if this is a function, then we should call it like a function. Does this make sense? I don't have to assign this to a variable and then call it as a function, do I? If it makes it more clear, I'm willing to. Okay. So we take the request here and the response here, and we just pass that along to this other function that's actually going to handle it. Okay. So now, sorry? Yep. These? So I'm taking, if I were to use the request or the response in this function like I was before, here. I'm just passing this value right into here, which comes into here. Let's set a breakpoint and we'll see exactly what's going on, okay? So I'm going to set a breakpoint here. I'm going to run it. And so now in order to trigger this breakpoint, I have to do something. What is it? When does this function get called? Sorry? So this function here. Right now I'm sitting, the server's running. I've set a breakpoint here, but when does this function actually get called? I have to make a request to the server, right? So I've not done that yet. That's why this breakpoint is sitting here, but the server's running. So once I make my request, this breakpoint will get hit, okay? So I make my request to /about. Oh, what did it like? Let's see what it gave us. Yeah, /about. So it made this request for me. It's this request object and this response object that I'm working with. This is what the HTTP library has given to me to work with. I'm going to do a lookup inside the route table. We can see there's 3 different routes that are handled here. //about /content or contact. And the URL that I'm looking for is about. So I believe that this condition is going to pass because it exists inside of there, right? So I step over this, and now I'm sitting in this line of code, okay? We got a request for something we handle, and so now this request that we have, that we got right here, that we would have just kind of used, or the response that we could have just used, we're not using it in this function anymore. We're going to pass it on. So I'm going to step into this function, and what this is going to do is it's going to execute this function and stop on the first line, okay? Is anyone surprised how we got into here? No? Okay. So this is what it's calling now. And this request and this response, it's the exact same one that I just passed into it. It's the one we would have worked with otherwise. Does that make some sense? These are the same objects. They just got passed in from here to here. And so now I'm working with them in this function instead. But they're not new. They're not different. They're all the same. Yes?
Yeah, the question is about the if statement.
Yep.
Because it says request.url, but URL isn't one of the keys. So is that
Mm.
something that's
Request.url, the request has a URL key.
has a URL key?
Yeah.
I guess I'm just because that has something to do with the module that's part of like HTTP built in.
Request.url? Or which part?
I'm just thinking of like how objects work. So
Mm-hmm.
if routes takes you to the routes object, and then request URL, like that line there is allowing you to.
Well, so this is just a string.
Yes.
And so it's something that represents the path, right? So in this case, it's /about. And if I were to just type in /about here, I mean, that would be, I'd be looking up for /about, right? But I'm looking up for whatever the user wants to see in here. Yeah, for sure. Right, so when the request is made, the HTTP library adds the URL to this object. I take this URL, which is a string, and I use it to look up inside this object here for the value that maps to that key. And the value that maps to that key is always going to be a function, so that I can call that function, pass the request, pass the response in, and then handle that there instead. And this is really just an organizational method here. Right? This is all we're doing is organizing our code a little bit nicer. I could have put these into the if-else statements, and they'd still be using the exact same request and response objects. I just pass them into there instead. So we set the response status code to 200. We can see on the response somewhere in here that the status code is 200. The response is going to have some headers. It's not seen. Oh, it won't yet. I guess we have to add one. So there we go. Our response now has. Don't know where it is. There it is. So we've added a header. And then the last thing we're going to do is what we'll call the sort of like the finishing move or whatever. It's the one that finishes the response. The response has not been sent yet. The response will only get sent when one of these finishing functions have been called. And in the case of HTTP, the only function we have is end. But later on, again, I'm going to show you, instead of end, we could use render.json, .send, or .end if we felt like it. So there are lots of different ways to do this. Once I run this code, it's going to send the response the response back to the user, or to the person who made the request in the first place. There we go. Okay, so does that roughly make sense? Okay, because we're gonna move away from this and then go into Express, do the same thing again using the actual framework or library. Any questions before we take a quick break? Victoria, good? Thanks, Gabe. Oh, I saw almost a response. Yeah. Okay. It's either a really long question or not one at all. Okay, well, let's take a 5-10 minute break, come back, do Express stuff. Let's go again. So we built a web server using the Node library, and so I promised we'd spend most of the time on Express. That's what I'm about to do, and it's kind of similar in how we start. So let's do this instead. Let's do this instead. Thank you. So I'm going to touch this file here, express server.js. Wow, having 3 S's in a row like that. I'll just do that instead. There, that's a bit better. So now I've got this file express server, and I'm going to start working from this instead. I've got the website up already. This is the Express website. Express is a fast, unopinionated, minimalist web framework for Node.js. They take pride in being minimalist. I think they're comparing themselves to things like Ruby on Rails. And really, they're just trying to make your lives a bit easier as web developers who want to build web servers, not having to actually use that HTTP library that has sort of a rough API. Let's look at Hello World, though. They've got a Hello World as well. And so here is their Hello World example. How does that look? Shorter than the other one, yeah. Write less, do about the same, right? So we'll put that right in here just like I did before. Let's talk a little couple of the differences. Because this code isn't going to work that I've just copied and pasted in here. Why is that? That's right. I haven't installed Express, so I have to go do that. Let's get that out of the way. And actually, I'll show you kind of a shorthand that you can do. npm I express like so. So now in my package JSON, I've got Express 4.16.14. Looks good to me. And so now this should actually work because I've actually installed the library that I need to use here. So let's run this thing. And let's see, what do we expect to happen if I put / in for my path? Like when I make a request to this and I just use the root path, what do I expect to happen? Just /. Okay, and if I put / about? Okay, same thing as hello. So we're assuming that this is kind of handling all requests like it did before. Is that right? It's not. There is a way to do that. I think it's kind of like this, where we don't define what method we care about. So that means every method could get handled by this. And I think we actually have to use this instead if we wanted to handle every single route with this. Does that make sense? So then what I get from this is what is actually only handling one request. It's a GET request to the / path. That's the only request this server's handling at this point in time. Make sense? Okay. So if I go to /, then I get hello world. And if I get / about, I cannot get about, but it's a 404. So it looks like Express is handling that for me. Is if I've not registered a handler with it for some route, then it's going to assume that it is a 404, and it's going to send that back for me automatically. Right? So that's already one of the benefits to using this. Is it's managing some of the code we wrote this morning. We don't need that because Express has written that for us. All right, but we want to support about. So that's what it takes, right? Add a new route handler. It handles GET requests on / about. Restart this. Now when I make my request, good. Doesn't give me a 404 anymore. But of course, if I go to / I get the other, the index route, and then I get 404s for things that don't exist, right? So this is already, I think, proving to be a little bit more straightforward. I think we could show it kind of in more reality of what we expect the code to look like, because I'm going to put semicolons on this too because it'll be consistent with the rest of my code. This is sort of what I would expect your Express server to start looking like. Oops. All right, something like that. Make sense? And so if we want to add another route handler, and maybe this is something we post. So we could app.post on contact. Now we're only handling a post request on /contact. If I restart this thing and I go to / I get hello world, and I go to / about, I get about world. But if I go to / contact, it says cannot get. And that's because I did not do a get. I did not do a post. I did a get, so it doesn't handle the get for this. Does that make sense? This is how we define what method to handle here. And again, use is general, but we want to be more specific. So maybe I want to actually handle this with a get. Change that. Ah, there it is. Okay. Actually, it's contact world. There we go. So it kind of makes sense? Yeah. Question is, can I make post requests with the browser? I can, but I do it through form input. So when I type into this browser bar up here, I'm making get requests. If I had a form on this page, then I can define what, and then I click a button that submits that form. I can define what method I want to use. So in that case, probably post, and then what path to trigger that post on. So if I wanted to create a contact form, that when I click on the button, post the information from the form, that's how I could do it. But typically we don't post. If I want to test my post though, we have tools for that, right? Because the browser is not the only HTTP client that we know about that we could use. Curl is an option. I can do posts with curl. I actually recommend Postman though. If I want to make this request here, let's see. So it's going to do a post request on contact. Now when I make my post request to / contact, this is kind of how I would test that rather than trying to, I don't need to set up a form to test this. I could just use Postman. So I run this, and here I got contact world back. But it did a post, it handled it as a post, and if I were to change this to get and make that request, cannot get / contact, right? So again, this is why I said it's so important for us to know about the methods get and post, and then also how paths work, because this is how users decide sort of what information they want from your site, or you decide what information you provide from your site. Let's do a quick review here, make sure. So I did this example. Good. All right. Let's talk a little bit about, any questions about that before I move on? Don't worry, the render stuff, that's all comes with EJS, which is after this. We'll add that in a second. Okay. So I want to start adding some HTML to this. I may as well do it here. And my the way that web pages work is right now when I make a request to / about, I'll just run that. Then we get this page back. Here's our response, and there's no other links or actually other resources within this. Normally, if we want to import, we want to show an image, we could use an image tag for that. And then an image tag needs a source attribute, and that source is most likely another file somewhere on a web server. So maybe that looks like something like this maybe. And so when I loaded this page, the first request that I did comes back with this content here, right? And then my browser renders that, and it parses all the HTML, and it comes across, well, this is no problem for it. It just shows that on the page. But then it gets to this image, and it says, well, I got this image that links to some other resource somewhere. So I need to link, I need that resource. And that is what's making this second request here. So we actually have two requests now, one for the original image, or the original page, and then when that page is loaded, it makes, on my behalf, a request for any of the images that are in that page. Make sense? But the thing we're noticing here is that when I do a request for /LHL.png, my response is not found. I can't get that, right? Because I'm not handling it. So does it make sense that we would maybe add app.get /LHL.png, and then what we do we go and find that file on the file system, load it up, and then send the contents of that back? I guess we could do that for one image pretty easily. But what happens if we want to put 30, 40, 50 images on our website? We don't want to create 50 routes for that. That's not a good use of our time. It's hard to maintain. So we're going to use something called middleware. This middleware that we're going to create, or that we're going to use, it's already created for us. Express provides it. What it does is it listens to every single request. And every request comes in with a path. And what it does is it takes that path and it says, do I have a file on the file system that matches this path? And if it does have that file, then it sends that back in the response. And if it doesn't, it says, I don't have a static file that matches this name. So that means that maybe you handle this route somewhere else. So we'll just fall through and let you kind of continue looking at the routes, and maybe it ends up being a 404 at that point. So when we use middleware, the documentation for this, at least this example here, is right here. App.use. So instead of app.get or app.post, I'm saying app.use. It means every single method would go through this middleware. Okay. Express.static. This is a function that I'm calling. It takes one parameter. It's the name of the directory that I'm keeping my static files in. So let's take this code, put that in here, and let's create the directory called public that I've pointed to with this, right? I'm saying public directory, look for files inside of here. And the reason I want to do this is because I don't want to open up my entire file system, all of the files to everyone. I don't want people to be able to, for example, make a request for expressserver.js and then see the JavaScript that represents my server code. That might be a security concern for me. So what I'm going to do is I'm only going to put the files that I want people to see, like lighthouselabs.png, into the public directory and only make those accessible to the web server. Cool? Lighthouse Labs. Oh, there it is. Maybe it's this one. And web servers live into the public directory that I created. Put that in here. Rename it to LHL.png. Okay. So now on my file system, I have that file that I want to load up and send back in the response. But I don't have to do that because the Express static middleware will do that. Call this function, tell it about the public directory. When the request comes in, the thing that this creates will handle it. I'll show you a little bit more about that. Let's just see it working first. Kind of, right? It's zoomed in. Let me zoom out a bit. So now it's actually able to find this image. And I don't have a specific handler for that image. So I just put all of the images that I want to now host on this website, or this web server, into the public directory, and then I'd be able to link to it in my HTML without an issue. Okay? Now let's go a little bit more into what this middleware actually looks like. This is how, if I wanted to create my own middleware, I'd have to create a function that took in 3 parameters. The first parameter is the request, the second one is the response, and the third one's a function called next. The logic would be, Try or grab the request.url. So we have the request.url. Maybe it's /LHL.png. Make sense? Okay. Grab that URL, LHL.png. Look within the public dir for the requested path. If it finds that, okay? If we find that file, response.send the file contents. Make sense? If we do not find that file, next as a function. Okay. So this next thing is just a function that expresses passing into the middleware. It says, if you're not finishing this response, then call next so that I can continue to look for something to finish the response. All this call to next is doing is saying that this middleware was not able to serve the file we were looking for, so we should let Express continue to look for a route that could do that. And the order matters. So this middleware will handle first, then this middleware, and then if it gets through these two and doesn't finish the response, then it will look here, then it will look here, and then once it gets to the end and it has nothing else to look for, it would send a 404 back. Does that kind of make sense? Okay. Yes.
About the middleware app, the middleware that you just wrote.
Yep.
Does it actually respond to send? Isn't that in the other one? Like, shouldn't it just sort of return it and fill in the gaps, or is it doing another response send?
So the question here is this response.send, right? Yeah. Should it be doing this? Is that the question?
Yeah, like, is it actually sending it? Doesn't that send it to the website? Or does it
To the client.
to the client? Or doesn't it just shove it into the app-get function that you're working on?
So yeah, I get what you're saying. So I think so. So basically, here, we've gotten a request and we know what the path is, and we know if there's a file that matches that path, right? And if there's a file that matches that path, that's the end of the response. That's the end of the response. We just send that file back.
But you're sending it back to the app-get function that you've written down below.
These functions, if so, in the case of here, let's kind of look at this, right? Let's see here. Hold 1 second. So, I can. Okay, just do this quickly. I'll set a breakpoint here. All right. So I make my request here. The first request that comes in is for /about, right?
Yeah.
Because that's the page I'm looking for. Is that, so I get that here. Do I have a file called /about inside of my public directory? No, I don't. The only thing I have in my public directory right now is lhl.png. Okay, so it didn't find /about as a file. So what it would do is it would call next and say, I didn't handle it, right? So we'd continue down here and say, yeah, call that. And what that means, oops. So hold on. Let's try that again. Okay. Here, I've got about. That's not the right one. So we continue down. We call next. And that next is telling Express that you're taking control back and you're now looking for another handler that could do this, right? Because the middleware wasn't able to handle that because it was /about. So in that case, it got down to here and it said, oh yeah, I do know how to handle about. So let me send back about world. Okay. We've sent about world back to the client, and the client took this HTML, parsed it all, found lhl.png as an image, and made the request to the server for that. And so here, request.url is now /lhl.png. So now the middleware is looking again in that public directory for lhl.png. Did it find it? Yes. And so now we don't need to do anything else to handle this response. We just need to send that file back. And so the middleware will do that for us. And that's why we didn't call next. We wouldn't call next in this situation. We would call response.send and send the file, or response.send file, or something like that.
Oh, I see. So because the image tag already was sent, and then the client side kind of resends to find where that image file.
It makes another request for that image file now.
So it has to be sent again.
and then in response we want to send that image file. So we could write a custom handler that understands /LHL.png, loads that PNG, sends it back in the response, or we have middleware that just generally looks at all requests coming in to see if we have a static file that matches that, and then sends the static file back if that's what you found instead.
Yeah, my question was mostly just about the line of response sent within that
Ah,
within the middleware.
yeah.
Just because I'm used to functions returning values that then get applied to the function that calls that function. You know, rather than because it's being sent to the client's making another request, which comes back, goes to apt-get,
Mm-hmm.
so it gets sent.
Yeah, yeah. Okay, cool. Good. Yeah. Perfect. That's great. Let's see here. I don't know exactly where they put it. Let's see if it's in here. Okay, so it's actually coming. I'm looking at the Express code right now, and there's actually coming from a module called serve static that they're requiring here. So let's see if they've included serve static. So serve static 1.3.12. So here's Express serve static library. If you look at index.js, then here is the serve static function. This is the function that's actually being called for that LHL.png request. And it is going to do things like let's see. I want to see where it finds the thing, where it actually. I think here's where it's actually checking for the file. It's a bit more complicated than I hoped it was, so it's probably not going to help us out very much there. Just one more thing I'll kind of show you. The reason why. So we've got this app.use static here. Remember, all middleware takes in request, response, and next. And so this thing here that I call what do we believe static middleware to be? I mean, technically a function's an object, a function. So I expect to be a function because if I'm able to pass this directly into here and have that work, right? Then that means that whatever this thing creates must be a function with this signature. Right? We might be able to actually even see that. Just 1 second. So request URL is lhl.png. And so this thing here, I'm about to call express.static public. Step over that. Static middleware, exactly what I expected it to be, is a function that has request, response, and next as its parameters. Okay? And that's why I was able to just pass that directly in as middleware. And you're going to find this with the middleware that we use. You're just passing in function calls, and those things return functions that have this signature. All of them do. Body parser, cookie parser. I'm just listing middleware you're going to run into this week. They all follow this interface. Make sense? Okay. We don't have to fully get middleware today, and we're not even necessarily going to be using middleware in this project. But I do recommend, if you are feeling a little bit more like you want to push things a bit, by the end of this project, before you submit, there are opportunities to use middleware. Okay. You could ask a mentor for some help on that. There is a requirement that you show the user's email address at the top of every single page. Okay, that's a repetitive thing. I wouldn't want to have to put that into every single handler that I create. So one of the ways, at first I might do that because I don't know about middleware, but once I learn about middleware, there's a way to do that more generally where you have one function that handles that logic, and then every route after that is able to use that information and show it on the page. I can't get into more detail than that because I kind of want you to explore that, but don't worry about middleware too much until for the next kind of 3 days or so. Yeah, there's a question there. No, I mean we can talk about it. I just don't want people to get too hung up on having to nail it right now. Middleware, yeah, I guess so. I mean, middleware is kind of like a helper function in the sense that it is reusable. It's more general, maybe. It's really just a way for us to be able to either tie in and we can have middleware that doesn't finish a response but does things, manipulates our request object, for example, or response object even. And then just calls next, and then it says continue looking for something. Now the thing that actually handles it has that request and response object that may have been manipulated in some way. Yeah, kind of like a helper. Yeah, I'd say that most middleware are pretty much helper functions that do common behavior that web servers need to do. For example, like serving static files. Okay. So here's middleware. There's definitely, they've got their documentation on this. It's in the, here we go, using middleware, writing middleware. It's in their guide. This is the power of Express, is middleware, though. This is where the power does come from. So once we get familiar with the basics of Express, then we want to make sure that we push ourselves into learning more about middleware to take full advantage of this library or framework. Here's an example of some middleware that doesn't actually finish the response. Here what this is doing is it's saying, I want to add to the every single request that comes through, I want to put a key on that request called the request time. And so when the request comes in, the first thing that happens is it calls this function, takes the request, adds that data to it, calls next, says, you continue looking for things to handle this. Then down here, when it actually handles the request, we can take that data that was added onto it with the middleware and send that back in the response, right? So now every single, doesn't matter how many of these handlers I have, every single one of them has access to rec.requestTime now. That's something we've added custom, right? Just an example. It's a lot going on there. And you're going to be using more middleware. You're not going to be writing middleware. You're going to be using middleware. You're going to be using middleware to do things like handle your cookies and parse the body data coming in from a posted form. But those things are tomorrow and the next day, as far as I know. Okay. What else? All right, we've gotten to EJS templates now. So this is sort of the last section that I want to talk about. It looks like we have some time for this, so it's good. There are lots of different templating libraries. If I go into, let's see, template engines, they've put it as an advanced topic. We're still going to do it. It's not a big deal. Template engines, or actually, that's developing. Never mind. That's good. We want using template engines. Good, not advanced topic. Here they're going to tell us that there are many different template engines that work with Vue, not Vue, Express. Here they are. Pug is one of them. Another one's called Mustache. EJS for embedded JavaScript. These are all different options we can use. It says here, the Express application generator uses Jade as its default. So the one we are going to use is EJS. So instead of npm install pug, we're going to npm install EJS. Okay. Now that I have EJS, and I can take a look at the package.json and see, yep, I've got EJS here. I need to tell Express to use EJS as its template engine. So in addition to creating routes on Express, we can set different configuration options on Express. So here we're going to take this app.set. I'm going to put it all the way at the top. I want to make sure that this happens at the very beginning before any of my, may as well do it here. And say EJS here instead of pug. Okay. Now you're noticing that I am not doing require EJS on this. I installed the module, but I'm not requiring it. And that's because here, when I tell Express to use this, it's going to actually require that library for me based on what I've put in here. So it does the require. If I didn't install the library, it would still complain, even though you're not seeing me use it here. Kind of weird, but and this is I think common for Express. Any of these engines that we put in here, Pug or Jade or Mustache, we wouldn't have to actually require them ourselves. We could just tell Express to require them for us. Once we've done this, we're pretty much ready to use that render response.render call that I had alluded to. But there's another kind of configuration thing that we want to think about here. There's a directory that we're going to create called views, and it's the views directory that's going to contain all of our HTML files. By default, it's called views, but if you wanted to, you could change the name of that folder. You could set that value to something else. You could call it templates or pages or whatever you want. I'm going to stick with views, so I'm not going to set any value there. But I do need to create that, oops, not in public, in the root, views. I've just created now a views directory here, okay? So anything that I put in here is now available to me for me to render. And I'll call these files .ejs files, because they're not HTML, because they're going to have a little bit of JavaScript in them, but they're going to look a lot like HTML. I don't know. How do I do this? It's been a long time. I don't care. HTML, head, body, but not Boyd. They lets you get away with anything, though. Title, index, and the body of this document is going to contain h1 index from EJS. Okay. So right now it's not really an EJS file because it just has HTML. I could just load this up. Actually, if I wanted to load up just HTML and not render EJS files, then I might just put these into my public directory and have that Express middleware load them instead, right? So bear with me. I'm just going to do HTML, simple HTML here first, and then we'll move over to actually using the EJS part of it. So here, res.render is what I'm going to use instead of send. Res.render takes in two parameters. I'm only going to need one at first. It's index. Okay? Because I'm using the EJS, because I've told Express I'm using EJS, I don't need to put .ejs in there. It knows to look in the views directory, and now it knows to look for an index file. Okay? Run this. And here we go, index from EJS. And if I look at the actual response here, it's that HTML that I wrote. Cool? So this is where we want to get to, right? We don't want our HTML to be in our Express server file. We want it to be separate, so we've accomplished that. I could also do the same for maybe just, is there a duplicate here? No, there's not. All right, now I got an about.ejs. And I will do the same down here, except about. Okay. So here's the index. Here's the about page. And I guess I probably want to put on my about page that image. Now, if I just put LHL.png in there, let's see what happens. Okay, good. It seems to work fine. It made the request to /LHL.png. So that looks good to me. I think we're pretty much on par with what we had before. So, oh, this is what I was looking for. That's what it is. Doc type. All right. Now we want to make these things dynamic, right? That's the whole point of EJS, is to actually do the stuff on the server, find the data from the database, whatever it is, create a list of those things as an HTML list, and then send that back in the response. I could hard code anything I want in here, but maybe I want to pass a little bit of data about that request to the HTML for it to render that for me. Does anybody know about, the user agent, right? When we all used that yesterday. We set the user agent when we were making requests to GitHub. What if we wanted to, on every request that we send back, tell the user which agent they used to make the request in the first place? That's dynamic, right? If I make the request with curl, I should get a different result than if I make the request with my browser. Let's test that out. First thing we can do is figure out where the agent information is, though. So where do we think that's stored? On the request. Yeah, so let's take a look at that right now. I'll make my request to / here. And I'm going to look at the request. Oh, it's probably a little bit easier if I go over the debugger and look at the request here. Good. Now, scroll down. Probably the headers. There it is. It's right down here. So when the request is made, if we look at the headers, we can see that there is a user agent header. And that says Mozilla 5.0, Intel Mac, etc., right? So what I want to do is figure out what the agent is. rec.headers.user_agent. Can't do that, right? Okay, so I'll fix it. So this is actually what happens sometimes. Sometimes I don't get to decide what my keys are called. So in this case, I'm forced into using this square block kind of notation to do this lookup, because otherwise the JavaScript would be, it would think I was doing rec.headers.user-agent, and that's not really what we're trying to do here. So I'm going to actually just do my second option for lookup. And so now I expect that the agent, is it a question? Head scratch? Head scratch, I think. Okay. So now this agent, that looks right. It's pulling that information from the request, Mozilla 5.0. So within my handler, I have access to this information. And the last step is for me to pass that information to my template so that it can add that into the HTML that it sends back to the client. This is where the second parameter comes in. It's an object. Okay? This object contains as many keys as you want, and those keys will all be available in the scope of the template. Does that make sense? I just take the agent key and I give it the agent variable value, which is Mozilla 5.0, macOS, etc. So now, because I've provided this template variables object, and if I said I can put more in here if I want to, but this is where the data that I want to send to my template goes into this object. Okay? So on here, now I need to take that variable called agent and display it on the page. Now we're starting to use specifically EJS syntax. Okay? I'm going to restart this one here. And I'm going to make my request. And so now the response that comes back is that agent string. And if I go into curl, then I get a different response. So it's dynamic. This is how we're getting data into our HTML, okay? I have my other variable there. I'm going to put a line break in there. HTML doesn't care about new lines, right? Let's put that line break in there. Now you notice I did not restart the server. I don't need to. I didn't change the server. In this case, I only changed this index.egs file. And when does it load this index.egs file? When I make the request, right? So I don't actually need to. It's not cached. I don't need to reload that or anything. I can just refresh, and I get my second string down here as well. Okay. So we do need to restart the server when we change the server file, but we don't need to restart the server when we change the EJS, because the EJS gets loaded, parsed, interpreted, and then sent back on every single request. Cool? All right. A few things going on here. There are a few different options for this. I'm always going to start with the less than and then the %. This is my EJS template. This says anything that's in between these tags should be interpreted as JavaScript. Does that make sense? Okay. So, what happens if I take out this little equal symbol? Agent is. There's a difference between these two here. One is that in one case it just evaluates the expression and then kind of just throws out what the actual result of that expression was. The other one, it actually writes it to the document. And so in the second case here with the equal symbol, this means write whatever this evaluates to the document, whereas this means don't write anything to the document, just run this code. Does that kind of make sense? So you're going to be kind of console. This would be kind of like console log. This will get. I'll use this and then maybe be a bit more straightforward what's going on there. So let's say instead of just the one agent header, I want to list out all of the headers. Right? So now I'm just pointing to the headers. I'm taking the headers object, and that whole headers object is going to be passed into the template. Okay? I do need to restart the server now because I've changed the server. And when I reload this page, it's going to die because, agent is not defined anymore, right? So we do get a little bit of error handling for this. I mean, it tells us warns about that. So I'll go back in here, and I'm going to change this, make sure it prints it to the page as well, or writes it to the page, and then headers. There we go. Okay. Well, it's printing out an object. That's not quite what we were looking for. How could we actually iterate through an object instead? For each? That would be array. Yeah, we could do that. Yeah. For in is really the only option with an object. Yeah. So here what I'm going to do is I'm going to create a list, an unordered list. And in here, each of the list items is going to be one of the headers. Okay. So I'm going to create one unordered list, and then within there, I'm going to create n number of list items. It depends how many headers I have, right? So for var key in headers, or let's say, even better. For var header in headers. Now notice I didn't put the equal symbol here, because I don't care about what this, I just want this to run this code, but I don't care what it actually, there is no actual result to this, or there's no output to this expression. So I'm just going to do it this way. And then for each of the headers, it's going to print an li. I need to also end that for loop here. So this kind of gets a little bit ugly. It's not my favorite in sort of templating here, but I'm able to do this for loop, and it will create an li for each item here. So let's read. All right, create an item for every header that I had. Oh, I think I do. Let's see. Well, I mean, header, if we want to write this out, we make sure we put the equal symbol. And so now this is going to tell us which header it actually was, right? Those are all my headers. Including agent is on there, user agent is on there, right? So that gives me the keys for all my headers. But maybe I want to put a colon there, and then I want to show the value as well. So I could do that. And so now it prints out both the keys and the values for each of my headers. Okay. And if I decided to make this request here instead, oh, there's only 3 headers. Okay. So it prints out 3 headers instead. Does that kind of make sense? Okay. I want to show you one more thing. Oh. Okay. So the last thing I want to show you is something that I noticed most people, like 50% of people get stuck with today, or not stuck with, but ask for help with today. So I'm going to just make sure everyone's listening. Okay. And I still assume some people will ask about it, but it's okay. It's okay to ask for help on this. You see here, I'm passing this object in, right? In your assignment, this would look more like is this any different? I'm still just passing an object in. I just gave it a name first, but then when I pass it in, it doesn't. The thing that I pass it to doesn't care about that name. Does that kind of make sense? So in my, even though I've put template vars here, in my template, it's still just headers. That's all it cares. That's all it really cares about is the key inside of there. And so what I notice some people doing is they see this here and they think, oh, well, that means that this is actually called template vars.header, and then they ask why that doesn't work. And it's because the template has no concept of template vars as a variable. It doesn't know anything about that. As far as it's concerned, it's just passed in this object like I did before, right? Okay, so don't let that catch you off guard. We're just passing an object in there, and the variables come from the keys of that object. It does not matter what that object was named in the server side. Make sense? Okay. If you do need assistance with that, still ask for it. I just want to make sure that I think that part of the assignment is actually kind of confusing. It continues to be confusing. All right. That is all of the material that I had for today. If you want to know a little bit more about EJS, we should look at, here we go. See these tags? I showed you 2 of them, right? I showed you 2 different options that we have. And those are the 2 options that we're going to be using today, and probably the 2 options that I use 99% of the time. But there are other things you could do with this as well. Keep that in mind. We always want to be going to check out some of this documentation to see what's possible, right? Because I'm not going to actually be able to teach you every single thing that this software can do. That's a good example. We want to write the username. We only want to execute this code. Cool? Great. Yeah, thanks everyone. Any questions from Victoria? I'll wait for any sort of response before I shut down the stream. Thanks everyone here.